Okay, so today we are talking about radicals some more. Remember that radicals are a special type of exponents essentially, so that's why these are all grouped together in the same lessons. I will go ahead and caution you, we're going to skip around a little bit. We've got about 5 problems on what you see projected that we're going to skip. So if you choose to work ahead, that's fine, but don't be surprised if we skip the problem that you were working on. So I'm telling you up front. Okay, so a lot of this is review. The review stuff we're going to kind of move through pretty quickly, but of course you can come see me if you have questions. So let's go ahead and start with the square root of 20 times the square root of 30. The square root of 20 times the square root of 30, remember you're going to multiply what's inside the radical. So this would be the square root. You could write it out as the square root of 600, but sometimes if you are on a non-calculator situation and you want to keep your numbers a little bit smaller, it's a good idea to write it out as 30 times 20, because then you've got smaller numbers to break down. If you want to multiply it out, that's totally fine, but it's just an option. So I'm taking the square root, so I know this breaks down to 15 and 2 and 5 and 3. 20 breaks down into 5 and 4 and 2 and 2. So what do I get to pull out?
5.
A 2 and a 5. So I have 2 times 5 times the square root of what's left inside? Yep, this 2 and this 3. So I end up with 10 root 6. Okay. Look at the next one. The square root of 3d to the 11th times the square root of 48d to the 7th. You can go ahead and multiply it out if you want, but I would probably leave it as 3 times the 48. And then d to the 11th times d to the 7th, I would multiply that. That gives me d to the 18th. All right, so I need to break down 48. I know that 48 breaks down into 3 and 16, right? What would be the benefit of choosing 16 here as a factor? Yeah, I already know it's a perfect square, right? So I can pull out a 4. What else can I pull out? Yeah, this is a 3 and a 3. So I've got 4 times 3. Do I have anything left over under the square root for that number? No. And then I want to think, okay, what's d to the 18th? What's the square root of d to the 18th? Yeah, because I think 2 goes into 18 9 times evenly, and there is no remainders. This is d to the 9th. So our final answer would be 12d to the 9th. All right, we're going to skip 3. Let's jump to 4. What would I do on number 4? Yep, I would need to distribute. Square root of 3 times 2 root 5. What's that going to give me? Good. 2 root 15 minus 3 times the square root of 12. Can 2 root 15 simplify? Nope. How about 3 root 12? Yeah, what can you pull out there? Yeah, it breaks into 4 and 3, which I can take the square root of 4, which is 2. So this is 2 root 15 minus, when I pull out that 2, what does this become? 6 root 3. Can I simplify that anymore? No. Question?
Couldn't 15 break up into 5 and 3?
It does break into 5 and 3, 15 does, but that doesn't, there's no perfect squares in there, so I can't take the square root of any of those. Right. Okay. All right, number 5, is anything different going to happen? No, we're dealing with cube roots instead of square roots, so just a little slight change in how we think of it, but the same as the exact process. So distribute your cube root of 2. Cube root of 2 times cube root of 4, what does that give me? Cube root of 8 minus 2 times the cube root of what? 64. All right, what is the cube root of 8? 2. And what is the cube root of 64? 4, and 4 times 2. So this is 2 minus 8, which gives us negative 6.
If the outside was like just square root, you couldn't do anything.
Well,
And then we can do it now.
you would, if this were just a square root of 2 instead of a cube root of 2, you would probably want to change everything into exponents because then you can add and subtract your exponents. Like you can multiply, no, because then you wouldn't have the same base. Don't worry about that.
Is that what we're doing with third division with the?
All right, I want you to try number 6, please. The cube root of a times the cube root of 2a squared plus the cube root of 16a squared. There's just a parenthesis here that we're missing. As you finish up, you can start to look up here. I'm going to start working it. But please finish working on your own if you haven't done so yet. All right, so you should have ended up with 3a times the cube root of 2. Any questions about that? Yes? What's your question? Yeah.
Where does the a go in the second part of the equation? Like, it's 2a times the cube root of a. And then
Oh, sorry, that's a mistake on my part. That should have said 2a times the cube root of 2. Because when you take a cube root of a cubed, you just get a on the outside. Cube root of 16 is 2 times the cube root of 2. Okay? All right, so we're going to skip 7. We will start with 8. What am I going to have to do on 8? Double distribute, yep. So 4 root 3 times the square root of 3 is 4 times the square root of 9, which is just 3. So 4 times 3 is 12. Minus 8 root 3. Then we distribute the 5. So we get plus 5 root 3 minus 10. 12 minus 10 is 2. Negative 8 root 3 plus 5 root 3. Negative 3 root 3. Questions on number 8? Yeah.
Wait, so when you distributed, did you do the full radical of 3
Uh-huh.
like all together?
Uh-huh. So you have, are you confused on this 12?
Yeah.
Okay, so this is 4 root 3 times root 3. What's root 3 times root 3? 3 times the 4. Okay? All right, look at 9. Root 3 minus root 5, the quantity squared. What do you have to do in this situation?
You have to multiply that by itself.
Yeah. Rewrite it so that you can double distribute. It just blended in with my squared. All right, so will you please go ahead and multiply that out?
What did you get? I mean, no labels. Whatever you got. Yeah. You have longer.
Plus 5. All right, so you should have ended up with 8 minus 2 root 15. Are there questions about that? Okay. All right, we're going to skip number 10. Let's look at number 11. Root 10 over root 6. What's the problem here? Why isn't this simplified? Good. There's a radical in the denominator, so we have to rationalize. How do we rationalize? By just root 6? Over root 6. Good. So this becomes root 60 over what? 6. 60 breaks down into 15 and 4. And why is that beneficial? What's the square root of 4? 2. So this is 2 root 15 over 6. Can we simplify that? Yes. Yep. What do we get?
Root 15 over 3.
Good. Alrighty, let's look at number 12. This time we've got the cube root of 8 over the cube root of 5. Okay, now again, We have a radical in the denominator, which causes a problem. We've got to get rid of it. The inclination is to take this and multiply it by the cube root of 5 over the cube root of 5. But let's see if that achieves our goal of getting rid of the radical in the denominator. If I take the cube root of 5 times the cube root of 5, what do I get? Cube root of 25. Does that simplify to get rid of my radical? No. So we're going to do it again.
So just multiply by the cube root of 25.
You could, yeah. So now what do I have in my denominator? The cube root of what? 125. Which does get rid of my radical because that just becomes 5. Now let's deal with the top. The cube root of 8 times 5 times 5. I could write it as 200. I could also write it as 8 times 25. Why would that be beneficial to me? Yeah, 8's a perfect cube. What is the cube root of 8? So this is 2 cube root of 25. Could you have simplified the cube root of 8 right here at the beginning? Sure. Questions on that? All right. Please go ahead and try number 13. What's all that's different in number 13? It's a fourth root. So what are we going to have to do? Yeah, we're going to have to do it one more time than we did before. So go ahead and try that. Okay, so let's look up here. So 4th root of 2 over 4th root of 2. 4th root of 2 over 4th root of 2. Why do I have to do it 3 times? Yeah, so that your denominator, in your denominator, you end up multiplying the 4th root of 2 by itself 4 times. So in the denominator, I end up with the 4th root of 2 times 2 times 2 times 2, which is 16. And in the numerator, I end up with 3 times 2, which is 6. times 2 is 12, times 2 is 24. I know that the fourth root of 16 is 2. 24, if you try and break it down, can you simplify that at all?
No.
Nope. So you need to leave it as the fourth root of 24. Questions on that? All right, let's look at 14. 1 over 1 plus the square root of 5. I have a radical in the denominator. But what do I do in this case when I've got a radical, it being added or subtracted from something else? Yeah, and do you remember what 1 minus root 5 is called? Yeah, you're going to multiply by the conjugate over itself. Guys, there's a lot of extra noise going on. Okay, so now go ahead and simplify the numerator. Going to distribute that 1, so it just becomes 1 minus root 5. And then what do you have to do on the denominator? Double distribute. 1 times 1 is 1. Then we've got negative root 5 plus root 5. What's positive root 5 times negative root 5? Negative root 25, which is negative 5. Okay? Is it coincidence that we've got root 5s that are going to cancel? No, that's by design. That's our intent. So on the numerator, I've got 1 minus root 5. What do I end up with in the denominator? Negative 4. Yeah.
If it was the starting problem 1 over 1 plus the cube root of 5, would you multiply by the conjugate twice? Or the conjugate and then the conjugate of the conjugate?
I don't know. I'd have to think about that. Okay? All right, we are going to skip 15 and 16. Shh. Guys, please stop talking. Thank you. We're going to go on to number 17. 3 root 2 over root 5 minus root 6. What am I going to do here? Okay, and what would the conjugate be in this case? Good. I like to put parentheses to help me remember that these all need to be distributed. So if I distribute 3 root 2, I'm going to end up with 3 root 10 plus 3 root 12 over root 5 times root 5 is 5. And then I would get positive root 30 and negative root 30, so those would end up canceling. And what's negative root 6 times positive root 6? Negative 6. So I'm going to get 3 root 10 plus, how does 3 root 12 simplify? Okay, I pull out the 2, and that 2 gets multiplied by a 3, so that's 6 root 3 over negative 1. No, 6 radical 3 is the same as the square root of 36 times 3. Okay, yes, that's the same. Okay, this negative 1, technically you're not going to just leave it down there. So that negative 1 causes all your signs to change. This is negative 3 root 10 minus 6 root 3. Questions?
You put like a negative in parentheses 3 root of 10 plus 6 root 3.
Sure. All right, I would like for you to try number 18 on your own. It's okay, I just think so. Okay. So multiply top and bottom by 3 plus root 5. In your numerator, you should have gotten 12 plus 7 root 5 plus 5 over 9 minus 5, which gives you 17 plus 7 root 5 over 4. You could split this if you'd like. 17 fourths plus 7 root 5 over 4. Those are both the exact same level of simplified and correctness. Okay. Let's look at 19. Okay, there's a couple different ways to approach this one. I'm going to show you the way that I think works best. That's my personal opinion. If you find a different way to work it, that is totally fine. Okay. Notice that I've got some complex looking thing divided by some other complex looking thing. Okay? It is a little complex. So, what we're going to do is we're going to simplify the numerator into one single fraction. Then we're going to simplify the denominator into one single fraction. Okay, so we're just going to kind of work through this bit by bit. Okay, so I'm going to start by, I want to combine 4 and negative 2 root 3. In order to do so, I need to have like denominators, right? Okay, so I need to get a denominator of the square root of 3, so I can multiply 4 by root 3 over root 3. Why am I allowed to do that? Yeah, I'm just multiplying by a weird version of 1. So this numerator becomes 4 root 3 over root 3 minus 2 root 3. Or sorry.
2 over root 3.
Yeah. 2 over root 3. So now do you see that we have common denominators? Yeah? So I can subtract my numerators. So I can write this as 4 root 3 minus 2 over root 3. Now, you could rationalize here. If you'd like, I'm going to wait and do that at the end. Okay? So now I'm going to go ahead and do the same thing with my denominator. So I'm going to multiply the 3 by root 3 over root 3. So I get 3 root 3 over root 3 minus 1 over root 3. Which gives me 3 root 3 minus 1 over root 3. Everyone okay there? Okay, so we now have a single fraction divided by a single fraction. Now when you divide fractions, remember, we keep the first one, change the division to a multiplication, and then multiply by the reciprocal. Yes? So 4 root 3 minus 2 over root 3. Change division to multiplication, and then multiply by the reciprocal of your denominator. Questions up through here? This minus 1?
Oh, wait, just kidding. Never mind.
Okay.
Sorry.
That's okay. Okay, I've got this fraction divided by this fraction. So I keep the first fraction, change division to multiplication, and then flip the second fraction. Okay, now remember with multiplication, I can cancel out these root 3's. So I am left with 4 root 3 minus 2 over 3 root 3 minus 1. Now, what does this force us to do? Now we gotta rationalize. How would we rationalize?
Multiply it by 3 over 3 plus 1.
Good. Everyone okay?
Can you just... Why can't you just...
Okay.
Why can't you just subtract?
What do you mean, why can't you just subtract?
Why can't you subtract 4 out of the 3 minus 2? Like we did. Like simplify. Yeah.
Because that rule, that subtraction rule, only works when those are exponents. Is that what you're thinking of? Yeah. You're only allowed to subtract these because those are exponent rules. Jason? Okay. So let's go ahead and distribute. We're going to have to double distribute. Par T. All right. So 4 root 3 times 3 root 3. 12 root 9, which is 12 times 3, which is 36, plus 4 root 3. And then negative 2 times 3 root 3 is minus 6 root 3, minus 2. Everyone okay with that? Oh, yeah?
Could you just multiply the radicals on the top to cancel out? Or did you have to cancel both the radicals out? Could you have done like 4 radical 3 minus 2 times radical 3, and then radical 3 times 3?
You could have like distributed here instead of canceling, but you would still have a radical in both the top and the bottom. You'd still end up having to rationalize. I'll go back and show that in just a second, okay? Okay, so now let's do the denominator. 3 root 3 times 3 root 3. 3 times 3 is 9, and then root 3 times root 3 is 3. So we would have 27. The insides cancel, so we have 27 minus 1. So we've got 36 minus 2, that's 34. 4 and negative 6 minus 2 root 3 over 26. Are we done?
No.
Almost. What do we have to do last? Yeah, we can reduce. Each of these coefficients can be divided by 2. So this would turn into 17. This would turn into negative 1. This would be 13. So this is 17 minus root 3 over 13. If you would rather, when you reduce, if you would rather split it and write this as 34 over 26 minus 2 root 3 over 26 and reduce it that way, 17 thirteenths minus root 3 over 13, that is totally fine too.
I see what I did.
Sure?
Yeah.
Okay. Okay, so this is one of those problems where mathematically it's not like this crazy, crazy hard thing. It's just long and tedious, and you got to make sure you keep your work organized. Okay, one more problem. Y over y to the 1/2 minus 2. Why is this not simplified?
There's technically a radical.
Yeah, what is that half the same as?
A radical.
Yeah.
Square root of y.
This is the same as y over the square root of y minus 2.
For that, you just subtract under your exponents.
But you're not, if you broke it up as y over y, no, you can't because, sorry, this whole thing is your denominator. You're dividing by this whole thing. You're not just dividing by y to the 1/2. So what do I need to do here? Multiply by the conjugate. What is the conjugate?
Y plus 2.
All right, go ahead and finish that one out for me. Distribute. Can you go any further than this?
Maybe. That should be a radical y. That should be a radical.
Oh, sorry, that should just be y.
Can you divide by y?
Cannot.
Y's cancel.
They cannot. The only way your y's would be able to cancel is if you were able to factor out a y of the numerator and factor out a y of the denominator. This is all grouped together, and this is all grouped together. You can't break it up. Blake?
I was like, why instead of multiplying it by root y plus 2, why couldn't you have done it just by the square root of y? Because that's all that is.
If you multiplied the top and the bottom here by the square root of y, when you distribute that square root of y, you would end up with negative 2 root y in the denominator.
Oh.
Other questions?
Could you not do it like y radical y plus y over y minus 2?
Say it one more time.
Y radical y plus y over y minus 2.
No. because you cannot just cancel in parts of a numerator or denominator. These are grouped together, okay? These are like stuck together. You can't just break them up. Okay?